Okay, so let's start. Last week I was still working on the owner tree implementation and was trying to debug in it, and also reviewed a couple recent PRs. And we just have a very quick meeting regarding to the C-Starized blue store, because according to CM, I believe that the the system won't work well with hard disk because it would involve a lot of read operation. That's me. I don't know. How's it going?
Hi, thank you. Can you hear me?
Yep.
Yes, I can.
Yeah. What I've been doing the past week is I've been working on the object class implementation for the CLS log functions. I implemented the corresponding functions in object class, and now I'm just working on um, well implementing the right functions in the PG backend. Uh, the functions returning the C star feature, basically. Well, essentially, for every new function that we implement in object class, we have to add a function in the backend for the OMAP operation. For example, OMAP read header. That's what I'm doing right now. So it's essentially it goes in. There are three stages or three places that you have to look at when you want to implement new functions for to support CLS plugins. You have to look at object class. You have to look at the ops executor, specifically at the execute OSB op, which is sort of the dispatcher, which was written by part of it was written by Rudek. And then you have the actual backend functions doing the actual operation. That's what I'm doing right now.
By backend function, you mean the API exposed by PG and which will be consumed by
yes
class objects. Okay, I see. Thank you.
Yeah, so just a little bit more context. Basically, in execute OSD op, you add a case for the type of op call that you're doing. For example, Ceph OSD op map get header or something like that. And then exactly what you said is the API exposed by PG backend for that dispatcher.
Okay, I see. May.
Yeah, at the beginning, I'm taking a look on the Ceph admin, and I found some others has already worked on it, and then I worked on the remove the hard-coded configuration for the messenger. The messenger source code has been changed, and the unit test for messenger has verified, but I found that the alien ICO test alien ICO doesn't work in the master branch, so I still need to fix the alien ICO unit test. Then the PR will be ready.
Thank you.
Hi, Chunmei.
Yeah.
Is alien echo is broken before your change?
Yes, just in the master branch, I didn't change anything. It's broken.
Okay.
Seems that the reactor is not initialized. There's non-pointer, and
I haven't looked at this test for a while. So I think I will also take a look.
Okay.
Mm-hmm.
So yeah. So there is the messenger configuration in the unit test for the alien echo, but before I change it, the master branch it still doesn't work. And yeah, so I'm working on the alien unit test. Okay, so that's all from me.
Thanks, Rudek.
Hello. I'm implementing the primary lock PG recover backfill counterpart in Crimson. Basically, all we do in the backfilling state. I had some issues with Crimson reaching the backfilling state. I had to solve a bunch of issues and solve one. Well, one of them has been actually worked around it. And I've got a question about it. Our peering machine, from time to time, runs some handlers of peering listener, like let's say on backfill reserved. In classical OSD, they are implemented as basically schedulers of events to the one huge main op work queue. So the code is actually the code of handler, the scheduled code, is actually mutually exclusive with the one that scheduled it. That's not the case in Crimson because we have when it comes to peering and recovery, there are two pipelines actually. One is the two operations: the peering event, local and remote, but they share the pipeline. And we got also background recovery, if I recall correctly. And background recovery doesn't operate, doesn't wait on the pipeline, on the PG pipeline defined in peering events. That's the reason why they are not that's the reason why they are not exclusive. And my question is,
I'm not sure in what sense does it need to be exclusive? What's the problem?
The problem is that the event scheduled on backfill reserved has been executed immediately without waiting in the queue, and I had to work around that by just running it at the very end of the state that's scheduled it. That's the reason why I had to move. That's the reason why I moved the code.
Why can't you add a lock so that both pipelines depend on that lock?
Okay, I see. Do you propose that that background recovery should just wait on the pipeline? Basically, you are proposing to share the pipeline between recovering between peering event and background recovery. Yep.
The purpose of these pipelines is just so that we can surface where a task is stopped. If you need to change them, go for it. Like they're not set in stone.
Okay.
Hang on. The purpose of those structures is not to be the only way of doing ordering. It's just I just created them as an initial example. Whatever you do to make it better or to make it more complicated, just make sure that anything that's waiting on whatever it is you introduce still gets registered up with the relevant waiting thing, where it gets dumped by the formatter. That's the important part. That's the part I really care about. That the OSD that we can basically a customer or a user can later say, backfill isn't working. What the fuck? And then they can go dump the current state on the OSD and say, oh, background recovery is blocked waiting on X because Y. That's the goal. So whatever you have to do to make that happen, go for it.
Okay, I was just confused by background recovery not waiting on the pipeline. I thought there is some good reason for that. If not, I'm going for that.
Ping me when you have a version of it, and I'll take a look. But yeah, I don't think there's any way that any of that is complete. It'll all pretty much have to be improved, made more complicated. There'll have to be more dependencies. We don't really want dependencies, but some of them do exist. So we can't just. I
see. Okay, at the moment, well, I plan to make those cleanups a bit later. At the moment, I just work around the stuff, and it seems operational. So.
Did it involve a change to peering state?
Sorry?
Did your workaround involve a change to peering state? Or is it entirely in Crimson?
Yep.
Okay, that's probably super dangerous.
I work around it by yeah, of course. It's not for match. It's just for developing Crimson.
Okay. Yeah. For development purposes, fine. I'm just pointing out that if it's very likely that callback is where it is.
Of course.
That's all.
No worries. Not going to mess with classical.
It's not always true, but it's true in a lot of cases. Okay, that's all I wanted to ask.
Okay, thanks for the consultation.
Hey, Ronan, how's it going?
Hi, everybody. Scrubbing, as usual, and home and work, too. A question which you might help me with. I'm playing around, like we said last week, I'm playing around with... thanks for the happy holiday. Yeah, we are on a shutdown and a holiday now. So the question is this. I'm playing around with the host, playing with scrubbing in old regular, planning to replace just for my development effort, planning to replace the scrubbing code with my code before moving it to Crimson. Do you know if I started discussing this last week, but do you know of an easy way of creating a problem that will be detected by either a scrub or deep scrub? I can always go and do some hacking into Monster, but
actually, that's
not. Can you hear me?
Can you hear me?
Yeah.
You can hear me?
I can.
Okay, I can hear you too. There's just latency. I will email you. There are a number of tests that do introduce scrub errors. You can borrow some of those.
Okay, good. Thank you.
So, how easy they are to run, I am less sure.
Sam, are you talking about the singleton test coined by okay, David. Okay.
Yeah, they're David's tests. Those are the ones. Let me find them.
Either if I can't run them directly, I can look at the code and do similar.
That's what I would recommend that you
do. Okay. So that's it for me.
I just wanted to make sure I understand you correctly. So the first step is to refactor the existing scrub code in classical SD, right?
Yes, not sure that I will be improving it. So I'm not planning for now to ever push it as a PR, but Ronan, just to make sure that it works. Yeah.
Ronan,
yes, John.
We're not doing another release for a year. If you can actually factor out a non-trivial amount of the logic, especially if it allows you to unit test it, then that would absolutely be worth it. For sure. No problem. Guaranteed.
Okay.
If on the other hand you find that what you factored out is actually not very interesting from a complexity or bug standpoint, then it may not be worth it. But it's absolute, if we think this is the thing that will be useful, I'm totally on board.
Okay, so what I do after I have this part, which will probably take 2 weeks or so, have this part working, I will share it with you and get pointers and the suggestion.
That was the point of factoring out peering state. It was a giant pain, and it's a little bit complicated, but it means we don't have a massive amount of duplicated code between Classic and Crimson. Any opportunity we have to make that happen is to our advantage.
Okay. Good, thanks. So that's it for me.
Thank you. I think that would be a win on the Classic side.
Yeah, that too.
If we can have a better code.
It will probably look better. I have some misgivings regarding the performance because I'm involving a boost state chart in the mix there, and boost state chart is okay, but not fantastic.
So you keep mentioning this, and if you're genuinely worried about the performance, then that's a reason not to use it in Crimson either. I will also point out, however, that it's scrub, and we're talking about overhead on the order of per object. So maybe it's not important. So if we can measure it maybe sooner rather than later and get a feel for whether this is genuinely something to worry about, that might be good.
Yeah. Once I have it working, this is one of the things I plan to do. Not on my machine, but something faster.
Well, I guess I'm up.
Yes.
Okay. I have a little doodad that lets me run unit tests that use futures and generally the C-star reactor in G-test because I wanted that. And I am implementing unit tests for C-star, or for C-store rather, this week. I took some of last week off, so I didn't get a lot done. But I do have the unit test framework, and I'm working on it now. It's straightforward. It just boots up the C-star reactor in a separate thread, and the G-test tests themselves just use a little helper to submit an operation to the reactor, and then throw the relevant exception if one shows up. That's all. There's not a lot to it.
So you are using G-test for testing the C-starized C-store, right?
Yeah, for testing C-store. All of the internal components are designed to be unit testable, so I'm backfilling unit tests for them now.
Okay.
Like I have an in-memory version of the block device, so we don't even have to make stuff on disk. I really want all this tree stuff to be testable, like exhaustively, without running an OSD.
Yes, I agree. I was just curious regarding to the test framework we are using for testing this C-star-based application, because we are using Assert in existing test targeting Crimson. So I think it's a little bit of code.
I prefer to actually just use G-test because you can use the filter. Like G-test has all of those little like convenience program options things that lets you filter which tests you want to run or whatever. It's just nice.
Okay.
That's its main value. Plus, if you look at like the existing unit tests for C-star, they have several dozen lines of boilerplate code. That's a little bit different between the different test files, which just bugged me. So I factored all that out to its own little library. That's all.
Okay. Hopefully we can follow your approach.
Basically, anything we can do to make unit tests easier to write is going to be to our advantage.
Yes, indeed. Vivian, anything you want to share with us? Hello? Okay. Xuehan.
Oh, sorry. Yeah, so since I think it's... Oh, go ahead. Yeah, actually, my first time to attend this meeting just because I'm trying to understand what's the major assignment for the persons who are working on the Crimson project. And since you are moving very fast on the C-stores design, the implementation, so that's why I would like to hear details. And you can just keep your pace to run your meeting. And if I have any questions, I will try to interrupt. Thank you.
Okay, thank you. Xuehan.
Last week I was modifying the pglog-based recovery code as Kofu and Sam suggested, and I was also working on implementing a clean shutdown of the current Crimson OSD because this clean shutdown is kind of important to smoothly run some test code about recovery, and I think that's all for me.
Thanks for looking into the Crisp shutdown. It's very important. I'll review your patch.
Okay, thanks.
No problem. Yingxin?
Yeah, can you hear me?
Clear. I can hear you.
Yeah, last week I helped Xuehan to debug and improve the OSD shutdown process. And for the heartbeat single connection, I wrote a rationale of my changes, detailed rationales in the PR, and I for the O-Node tree. Last week I talked with Kefu to decide what to do next about the prototype, and I'm trying to define the scope of our synchronous prototype. The first part is to define the interface, define the interfaces of the potential users of the O-Node tree. I think the potential users include. Let me just.
It's an internal interface under cstore.h, basically.
Yeah. Yes. But I want to see who will use that interface from the object store level. So I checked the blue store and object store interfaces. So I listed them in my changes, and they are transaction, no create, touch, remove objects, and collection list to list a range of all nodes, I think. And there's some logics in the FS check in Blue Store. I think it's using the iterators of I think it will use the iterator of the O-Node tree. So I think those are the major users of our O-Node tree. And I also try to define the interfaces of the simplified transaction manager and the logical cached extents. I paste. So our current goal is to implement the synchronous memory-based prototype. So I also want to have a simplified dummy interfaces from the transaction manager and the logical cached extent to manage our dummy logical blocks. So that's the two parts I was working on last week.
Just one thing, I think sometimes we can use recursive extensively because it's unlike in POSIX program model, the async recursive is we can have it for nothing, for no head, because we just run a continuation to reactor and we'll get it.
So what do you mean by asynchronous recursive?
Because every operation involves an asynchronous operation, you pass a continuation back to the reactor. So if your stack is too deep, it's going to trampoline back up anyway. And you literally don't have the option of not doing that. So
yes, that's exactly what I want to see.
So do you mean in the current we cannot simplify the futures?
No, I just want to say that you don't need to worry about the recursive function calls because we can use it without any overhead if it's involved async.
Mm-hmm. Yeah, but I think in our prototype we don't need to worry about the asynchronous.
No, it's actually easier to write a B tree. Right. So the dumbest, simplest way to write a B tree is recursively. And Kifu was saying in this instance, because we will eventually be writing it asynchronously, we may as well do that.
Okay.
Yes, we can start from recursive implementation without unrolling it manually.
Okay. So that's all from me.
Thank you. Any other things or questions? Okay. See you next week. Later. Have a good one.
Thank you. See you.
Bye.
See you next week.
Bye.
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 Bye.